Yo, so I updated my Blender add-on that helps to rig vehicles for the Unreal Engine, and in this video I'll show you how to use it and what's new in it. If you don't want to use the add-on, I will also show a simple method on how to rig vehicles without it, and also I will try to answer the most common questions that I have seen in the past 6-7 years about the Unreal Engine vehicle rigging, setup and things like that. To install the add-on, first you need to download it. There's a link in the description to all the places from where you can download it. After you have it downloaded, open Blender and click Edit, then Preferences and open the add-ons tab. If you have a previous version of this add-on installed, uninstall it. Then click on this small button and then click Install from disk. Then find the zip file you just downloaded and click on the Install from disk button. After it is installed, you should see the UE Vehicle tab in the viewport sidebar. You can open the sidebar by pressing the N key while your mouse cursor is in the viewport or by clicking on the small button. If you have rigged vehicles in Blender for the Unreal Engine before, then you might recall that in Blender you had to set the scene unit scale to 0.01. Now with the new version of the add-on, as long as you export your model by using one of these two buttons, you don't have to do that anymore. But if you want to, there is still a scene setup tab with a few more buttons that might be useful for you. Before rigging the vehicle, the first thing to check is to see if your vehicle is facing towards the positive x-axis. You can see the axis at the top right corner of the viewport. If it's not facing the right direction, just rotate your model around the z-axis until it's facing the right direction. And now you can use the add-on's object pickers to pick your vehicle's body and wheel mesh objects. You can do that by clicking on the eyedropper icon and then clicking on the mesh object directly in the viewport, or you can click in the middle of the picker and select mesh from the drop-down list. Also, if you are not really sure which object picker is for which wheel, just put your mouse cursor over it, and after a second you should see a tooltip with more information about it. After you are done with selecting everything, click on the Rig Vehicle button and you should see bones placed in your vehicle's body and wheels. And you also should be in a pose mode, where you can click on each bone and move it around to see if everything was rigged as you wanted. Now there's a chance that some of you now have a question. What do I do if my vehicle model does not have separate mesh objects for wheels and body? Usually, the most common case is that your vehicle's body is made out of several separate objects, and maybe even each wheel is made out of several separate objects too. So if you want to merge objects, while in the object mode, hold down the Shift key and click on the object you want to merge, and then use the Ctrl+J keyboard shortcut to merge them together. Or, if you want to split an object, open the object in the edit mode, select the part you want to separate out of the object and press the P key on your keyboard. And then from the menu, choose selection. And now you should have that selection as a new object. If you don't want to join your mesh objects together, I have added a new functionality in the add-on that lets you add mesh objects to the rig without merging them together. But more about that later in this video. Before exporting the vehicle, it's a good practice to check if your model normals are set up correctly. To check that, open the Viewport's overlay menu by clicking on this button and then check the face orientation checkbox. And then look around if your vehicle has any red color like this in the places that are supposed to be seen by others. If your vehicle was red before enabling this option, then you can switch to the wireframe mode and disable the X-ray to see things better. Usually, you can fix that by selecting the mesh object with the red part, opening it in the edit mode, selecting it all by pressing the A key if it's not already all selected, and then pressing the Shift+N keyboard shortcut to recalculate normals. And it should fix the issue, but sometimes you might have a model like this that might become red in places where it wasn't before. If you also have a problematic model like this, skip this video further to the section where I talk a bit more about how to fix normal issues like this. So now, after you have rigged your vehicle, you need to export it. If you have seen some of my previous vehicle rigging tutorials, then you might recall that in those, you would export models in the FBX format. But now, since the Unreal Engine 5.1 release, there's an updated GLTF importer for the Unreal Engine that makes that format also good enough for vehicle models. So in which format should you export your model? I have not done an in-depth comparison between both formats, but I have noticed that when importing a GLTF format file in the Unreal Engine, it does a better job of importing materials. As an example, I exported this vehicle model from Blender in both formats. And this is how both of them look in Unreal Engine without any adjustments. As you can see, the GLTF model materials look more like materials in Blender, and they are created as material instances and not as new separate materials. So if you want to transfer more materials from Blender to the Unreal Engine, then you should probably use the GLTF format. But keep in mind that this kind of GLTF importer in the Unreal Engine has existed just since the Unreal Engine 5.1 release. So if you are noticing some issues with it, try using the FBX format. So to export your model, click on the FBX or GLTF button and then save it to your preferred location. Also, you might notice that when you press the GLTF export button in Blender, all bone rotations change. Whenever you press the addons GLTF or FBX export buttons, it adjusts the rig for the selected format, so it will work in the Unreal Engine. So remember to use the addons export buttons when exporting the models. They do a bit more than just opening the export dialog in the preset settings. Before setting up your vehicle model in the Unreal Engine, you need to make sure that your project has the Chaos Vehicles plugin enabled. To do that, click Edit, then Plugins, and in the Plugins window, look for the Chaos Vehicles plugin. If it's not enabled, enable it, and then restart your editor. To import your model in the Unreal Engine, open the content browser and drag and drop your file into the place where you want to import it, or click on the Import button, and in the window that opens, select your file and then click Open. After you do one of those things, the Import Options window will show up. You should be alright by using the default import settings for the FBX and GLTF files. But as I mentioned before, the FBX file imported materials usually aren't too great. So most of the times when I import FBX files, I uncheck the Import Materials checkbox and then manually make and set up materials by myself. But that's just my personal preference. So after you click Import button, after some time, you should have your vehicle assets imported. Before proceeding with the vehicle setup, open your vehicle's skeleton asset and click on the root bone. And in the details panel, check if its rotation is 0 everywhere and the scale is set to 1. If it's not, then you could edit your skeleton in the Unreal Engine to fix that. But there's a chance that the whole model isn't rigged correctly. So I would suggest you skip this video further to the section where I talk a bit more about common vehicle setup issues in Blender. Usually, when you import a model in the Unreal Engine, auto-generated physics assets are not great for vehicle rigs. To fix that, open the physics asset and then press Ctrl+A to select all physics bodies and then press the delete key to delete them. Then click on this button with a gear icon and click on Show All Bones, and then select the root bone in the skeleton tree, and then in the Tools panel select what type of physics body you want to generate. Usually for the body, a single convex hull type is good enough. Then click on the Add Bodies button and then check if the new physics body looks alright. Just make sure that it's not going below the wheels, so it doesn't hang the vehicle in the air. Also, you can move, rotate and scale the physics body if you want to adjust its placement. If you have a vehicle where wheels are somewhat outside of the vehicle's body, you might want to select your wheel bones and add sphere type physics bodies to them, so they would have better collisions when they are hitting the other physics bodies in the world. The next thing you need to set up your vehicle is wheel blueprints. So create a new blueprint and in the Pick Parent class window, select Chaos Vehicle Wheel as the parent. For me, this will be a front wheel blueprint, so I will rename it as BP_front wheel. After it is created, open it and adjust it for your needs. For a basic drivable vehicle, you just need to change a few things in it. For the front wheel, you need to change the axle type to front and check the affected by steering checkbox. And also, you probably want to adjust the wheel radius. You can either guess it or just check the size in Blender. So open your model in Blender and while in the object mode, click on the front wheel and look at its dimensions. In my case, I can see the dimensions on the Y and Z axes are 0.4 meters. So I can assume that the wheel's diameter is also 0.4 meters and the radius is half of that. So I will set my wheel radius in the Unreal Engine to 20. There are more settings for wheel friction, suspension and brakes, but you don't need to change them to make a basic drivable vehicle. Just know that they are here if you want to adjust them later. Now let's make another blueprint for the rear wheels. You can create it just like the previous blueprint, or you can just duplicate the previous blueprint by right-clicking on it and clicking duplicate, or by using the keyboard shortcut Ctrl+D. Because it's my rear wheel blueprint, I will rename it to BP_rear wheel and then open it. Then change the axle type to rear, and usually rear wheels are affected by the handbrake, so you probably also want to check the affected by handbrake checkbox. And if your front and rear wheels aren't the same size, you probably also should adjust the wheel radius. And lastly, you also might want to make sure that the affected by steering checkbox is unchecked. Or if you want to have like one of those expensive cars with a rear wheel steering, have it checked and set the max steering angle to a negative number like -10. And now your car should have that expensive rear wheel steering. The next thing you need is an animation blueprint. To create that, right-click on your vehicle's skeletal mesh, then go to Create and click on Anim Blueprint. Open it and change its parent class to the vehicle animation instance. You can do that by clicking File and then clicking on the Reparent Blueprint and selecting the new parent class, or by clicking on the Class Settings button and then changing the parent class in the Details tab. And then in the animation graph, take the mesh space reference pose, connect it to the wheel controller and then connect it to the output pose. And that's it for the animation blueprint. And the last thing you need to do before creating a vehicle blueprint is to set up inputs. Right now, there are two ways how you can set up inputs in the Unreal Engine. You can set them up in the Project Settings Input tab, which is an older way, or you can use the Enhanced Input System. The first way is deprecated, so it just makes sense to use the Enhanced Input System. To organize things, I'll make a separate folder for inputs, then open it and create a new input action asset. This one will be for the vehicle's throttle input, so I will rename it to IA_throttle. Then open it and change its value type to axis 1D. In a similar manner, you need to make inputs for brakes, steering, handbrake and looking around. You can do that quickly by duplicating the throttle input asset 3 more times and then renaming them. And after you have them renamed, you need to change the look around input action value type to axis 2D and change the handbrake input action value type to digital. Here is what value type each input asset should have if you want to check if you set them correctly. And after that's done, create a new input mapping context. And then in its mappings, add all the input actions. And then set the keys you want for each input action. For throttle, I set it to the W key. For brake, I set it to the S key. For steering, I set it to the A and D keys. And for the A key, I added a negate modifier. For the look around input, I set it to the mouse YX 2D axis. And for the handbrake, I set it to the spacebar. Now you can create your vehicle blueprint. Create a new blueprint and as the parent class, select Wheeled Vehicle Pawn, then open it and click on the mesh component and set the mesh to be your imported vehicle mesh. And set the animation blueprint to the one you created before and check the Simulate Physics checkbox. Then add a spring arm component to the mesh component and then add the camera component to the spring arm component. Then adjust the spring arm length and position until it seems good enough for you. After that, you need to set up wheels in the vehicle movement component. Click on it and in the details panel, find the wheels setups and then set up your wheels in it. Change bone names to your wheel bone names. If you don't remember them, you can check them in your vehicle's skeleton asset and set the front wheels wheel class to the front wheel blueprint and the rear wheels to the rear wheel blueprint. Then look for the engine setup section and under the torque curve, click the Create External Curve button. Select where you want to save it and open it. So this is how a somewhat realistic torque curve should look. At least that is how it looks in the Unreal Engine's vehicle template. You can either copy the curve from the vehicle template or search for a real car's torque curve and try to recreate that, or just be lazy like me and add 2 keys and set the first key coordinates to 0, 0 and the second one to 1, 1. And now the last thing is to set up inputs for your vehicle. So open the event graph, find the begin play event and add mapping context to it. Then make a throttle input action node and connect it to the vehicle movement component's set throttle input node. Make sure that from the input actions node, you also connect the completed output to the set throttle node. And don't forget about action value too. And in a similar manner, set up brake and steering inputs. For the look around input, you will need to add relative rotation to the spring arm. You can right-click on the delta rotation value and click on the split struct pin to split it into multiple inputs. And then you can connect input X value to delta rotation's Z value and input Y value to the rotation's Y value. And finally, you can add the handbrake input. For this one, use 2 nodes of set handbrake. Connect the first one to the triggered output and the second one to the completed output. And then make sure that for one that's connected to the triggered output, you have a new handbrake checkbox checked, and for the other one, it's unchecked. And now your vehicle should be drivable. Drag your vehicle in your level and click on it, and in the details panel, make it to auto possess player 0 or change your game mode's default pawn to your vehicle blueprint. And now when you play the level, you should be able to drive your vehicle around. If something is not working, just double check if you accidentally didn't forget to do something, or try to rig a simpler car model in Blender and try to get that working in the Unreal Engine. Now let's go back to Blender and check what else you can do with the addon. So one of the new features I have added in this update is the addon preferences. If you open the Blender's preferences and open the addons tab and find the Unreal Engine Vehicle Rigger addon and expand it, you will see that now you can change the default names for bones and other things. And also there's a button which will open the addons web page. The next thing is the N-wheeled vehicle checkbox. So if you want to rig a vehicle that has more or less than 4 wheels, you check this checkbox and then you will see that instead of having 5 object pickers, you have 1 object picker for the vehicle body and the add wheel button. If you click on the button, you will see that it adds an object picker for the wheel. Click again and it will add another object picker for the wheel. As you can see, by default they have names, wheel, dot and its number. Those will be the bone names. When you rig the vehicle, you can change them by clicking on them, or you can change the default name in the addons preferences by changing the N-wheel bone name. For example, if I change the default name to the banana and then again click the add wheel button, I will get an object picker with the name banana. Also, you can remove the wheel object picker by clicking on this small button at its right side. So for example, if I wanted to rig a vehicle with 6 wheels, I would click 6 times on the add wheel button, then pick 6 wheels, and then do the same steps as before for a basic rig. And then in the Unreal Engine, instead of setting up 4 wheels in the vehicle movement component, I will need to set up 6 wheels, and then I should have a drivable 6-wheeled vehicle. Another new feature I have added is the Rig Calipers Mudguards checkbox. If you have rigged vehicles before, you might have noticed that some car models have brake calipers, and if you rig them together with wheels, they will be spinning in the wheels. or if you do not rig them with wheels, they will clip outside the front wheels when you turn them. Or if you are trying to rig a tractor or buggy-like vehicle, you might face the same problems with mudguards over the wheels. Usually, to fix the issue, you would duplicate the wheel bones manually and rig the calipers separately to the duplicate wheel bones. Now you can just simply check the Rig Calipers Mudguards checkbox, and then you will get separate object pickers for calipers. Then you just need to use those new object pickers to pick your caliper objects, and then you can just rig your vehicle. And you will see that you have additional bones for calipers. They will be named like the corresponding wheel bone, but with the letter C before it. You can change the caliper bone prefixes and suffixes in the addon's preferences by changing these two values. For example, if I change the prefix value to thick underscore and the suffix to underscore 69 and then re-rig the vehicle, we will see that caliper bones are now called by these nice thick names. And there's one more setting that you can change for the caliper rigging. It is parent calipers to wheels checkbox. If it's unchecked, calipers will be parented to the root bone, just as the wheel bones. And if it's checked and you re-rig the vehicle, caliper bones will be parented to the corresponding wheel bones. But just rigging calipers will not magically make them work in the Unreal Engine. So there are two ways how you can set them up, either by using animation blueprint nodes or by using a control rig. Let's start by looking at how to do that with animation blueprint nodes. So if you had the parent calipers to wheels checkbox unchecked, when you rig your vehicle, you will notice that without setting anything up, calipers look somewhat alright until wheels are turned. Also, if you drive over a bumpier road, you will notice that they seem detached from the wheels. So first, let's fix the detachment issue from the wheels. In the animation blueprint, after the wheel controller, add a copy bone node, and in the details panel, as a source bone, select the wheel bone, and as a target bone, select the corresponding caliper bone, and in the node, check the copy translation checkbox. And now, if we drive over the bumps, we will see that the brake calipers are attached until you start to turn your wheels. So to fix that, after the copy bone node, add the look at node, and in the details panel, as a bone to modify, set the caliper bone, and as a look at target, set the corresponding wheel bone. And now if we do a test drive, we will see that the brake caliper goes all over the place. And that's happening because we haven't set the right look at location. If we check the look at axis value, we will see that it will use the Y axis to look at the target. And if we look at the look at location value, we see that it's offsetting on the X axis. You can see a gizmo of the location in the 3D viewport and move it around to get an idea how it's working. To get the caliper to look in the right direction, we need to set the look at location aligned to the Y axis. So set X to 0 and Y to something bigger than 0. I will just set it to 100. And now if we do a test drive, you will see that it's working as it should. And now you just need to repeat the same thing for the rest of the wheels. And now let's see what to do if you had the parent calipers to wheels checkbox checked when you rigged your vehicle. You will notice that without setting anything up, calipers are attached to the wheels when you turn them, but they rotate around with the wheel when the vehicle is driving. So first, let's remove rotation with the wheel. In the animation blueprint, after the wheel controller, add a transform bone node, and in the details panel, as a bone to modify, select the caliper bone and change the rotation mode to replace the existing. And now you will see that the calipers are behaving just like in the previous example after we used the copy bone node. To make it turn together with the wheel, just add a look at node as we did before, and as before, as a bone to modify, set the caliper bone, and as a look at target, set the corresponding wheel bone. And for the look at location, change X to 0 and Y to something bigger than 0, and then repeat the same things for the rest of the wheels. And now let's look at how to fix calipers by using a control rig. The first thing you need to do is to create a control rig. To do that, right click on the skeletal mesh, go to create and click on control rig. And now in the vehicle's animation blueprint, add the control rig, and in the details panel, as the control rig class, select your just created control rig. So, if you had the parent calipers to wheels checkbox unchecked when you rigged your vehicle, open the control rig, and after the forward solve node, create a set transform node, set an item to your caliper bone, and expand the value input. Then create a get transform node. As an item, select the corresponding wheel bone and expand the transform value output. Then hook the wheel bone translation output to the caliper bone translation input to fix the issue where caliper isn't attached to the wheel. And for the rotation, you just need the Z-axis rotation. To get that, you need to get Euler angles of the rotation. And then for the caliper bone, create a rotation from the Euler angle by just copying the Z-axis rotation from the wheel. And now if you do a test drive, you will see that the caliper is jumping between two positions when you are driving. To fix that, for the Euler node, change the rotation order to one where it starts with the Y. And now just repeat the same thing for the rest of the wheels. And if you had the parent calipers to wheels checkbox checked, when you rigged your vehicle, you just need to set rotation for the caliper bone. You can either use the set transform or set rotation node. Set an item to your caliper bone in it, and then get the corresponding wheel bone transform and do the same Euler angle thing as before, and repeat it for the rest of the wheels. Another new feature I have added is a separate bone for vehicle body checkbox. If you check it and rig a vehicle, you will see that now there's one more bone, which is rigged to the vehicle body. I saw that people would add this bone manually to the animation vehicle rigs, so they could separately animate the vehicle body. So now they can add this bone faster. And the last feature in this panel is the bone length value. It just changes how long bones will be in the Blender's 3D viewport when you rig a vehicle. The next panel is the additional rigging panel. So if you have rigged your vehicle and want to additionally rig the vehicle's doors, steering wheel or other things like that, this panel will help you to do that. So the first thing you see in this panel is the vehicle armature picker. It tells the addon which rig it should use when doing additional rigging. So if you want to use any feature in this panel, the first thing you need to do is to set the vehicle armature to your vehicle's rig. And after you do that, you will see that below it, two new inputs show up. Parent bone picker and new bone name text box. More about them later. Further down, we have the edit mode rigging section. As the name says, this feature is used in the edit mode. For example, I have this model and I want to rig a steering wheel for it. So I will select the mesh object that contains the steering wheel and open it in the edit mode. Then I will set where I want the new bone's head location to be. I can either set it manually by putting numbers in, or I can select some part of the mesh and click the set head location button, and it will set the head's location to the center of the selection. So for the steering wheel, I want the head location to be somewhere in the center of the wheel. So I will select this vertex at the center of the wheel and click the set head location button. And now I can see that the head location has been updated, but by just looking at the location's numbers, it's hard to tell if the location is where I want it to be. So to check if it's set right, I can click the set 3D cursor to this button, and the 3D cursor will move to the head's location. And now I can see that the location is set to the vertex I selected. Next, I need to set the bone's tail location. I want the bone to act as wheel's axle, so it needs to be placed perpendicularly to the steering wheel. So in this example, I don't have a single vertex that I could select like I did for the head location. But there's this ring that I can easily select, and I think that its center should be good enough for the tail location. So I will press the set tail location button and then press the set 3D cursor to this button to check if it looks good enough. It seems good enough for me, so now I can proceed with adding a new bone to the rig. But I can't do that yet, because the add bone button is disabled. If I hover it, I can see that it's usable only in the edit mode, and the parent bone needs to be set. So let's go back to the top of the additional rigging panel and set the parent bone. Because my rig is simple, I'll set the parent bone to the root bone, and if I didn't care how my new bone will be named, I could leave the new bone name field empty, but I want it to be named as steering wheel, so I will type that into the new bone name text box. And now the add bone button is enabled, but before pressing that, there are two checkboxes above it. If the auto weight selected checkbox is checked, then it will automatically rig the selected mesh to the new bone. So, if I wanted to rig the steering wheel to the new bone, I would select the steering wheel mesh and then click the add bone button. And then if I go out of the edit mode and open the bone into the pose mode, I will see that the steering wheel is rigged to the new bone. And if the auto weight selected checkbox is unchecked, it will just add the bone without rigging anything to it. And if the end in pose mode checkbox is checked, after you add the bone, it will automatically put you into the pose mode, so you can check if your bone is rigged as you wanted. Also, I need to mention that this edit mode rigging functionality might be a bit buggy with the undo function. So if you undo after pressing the add bone button, there's a chance that your bone's tail and head locations might change to the previously set values. Further down, we have the object mode rigging section. As the name says, this feature is used in the object mode. So this is the new feature I talked about before in this video, for those who don't want to join their mesh objects together. Before this update, I noticed that some people found a somewhat creative way to use this add-on to rig a vehicle's doors or other things like that without merging them to vehicle's base. For example, I have this model and it has separate objects for wheels, body and doors. So instead of merging doors to the vehicle's body, I will check the N-wheeled vehicle checkbox, select body and add 6 wheel pickers, one for each wheel and one for each door. Then I would use pickers to select all wheels and doors and then just rig the vehicle. Open the armature in the edit mode and move the door bones to the place where the door hinges would be located. And now these two bones can be used to control the vehicle's doors. So after seeing that people are doing this, I made this object mode rigging section. And now if I wanted to rig the doors of the vehicle, I would rig the vehicle in a normal way, and then in the object mode, I would select one door, select the vehicle armature, set the parent bone for the new door bone, type the new bone's name, and then click on the create bone and add button. Then I would select the second door, change the new bone's name, and because I want to edit the new bone's placement after this, I will change the end mode to the edit mode. And then again, click on the create bone and add button, and again, move the bones to the door hinge location, and both doors are now rigged. This feature might seem a bit more complex than the previous method I showed, but it gives you the ability to select the parent bone for the new bone. It also allows you to select multiple objects and add all of them to the new bone at the same time, and also you don't need to re-rig the whole vehicle every time you want to add a new object to the rig. And there's also another button called Just Add to Bone. It will simply add all your selected mesh objects to the chosen parent bone. For example, I have rigged this vehicle, but if I move it up, you can see that one tire isn't rigged to it. So I can click on the tire and as a parent bone, select the corresponding wheel bone and click the Just Add to Bone button. And now the tire is rigged to the bone. Also, this button is quite useful if you want to rig something like a robot arm. Usually, you will need to parent the object to the rig, then open it in the edit mode, and assign the right bone vertex group to it. This button is a decent time saver in the hard surface rigging. In this panel, you can quickly check the mesh object weights and update them. You can click on the Get Active Object Weights button to show the active object weights, or just use the Troubleshoot Object Picker to select the object. And then, if you want, you can change the weight values of the object and then press the Update Object's Vertex Weights button to update the object weight values. And the last panel is the Scene Setup panel. In it you can set the scene unit scale to 0.01, reset it back to 1 and 100 times upscale or downscale objects. Since I have added the FBX and GLTF export buttons that automatically set up model scales, there is no real need to use these buttons for vehicle rigging. But maybe some people found them useful outside the rigging, so I left them and also fixed some minor bugs for them. One of the issues I have seen brought up by some people when they are using the add-on is that when they rig a vehicle, it goes all over the place. Usually that happens because of the object hierarchy. Sometimes when you import a model in Blender, you will see that it's made out of several empty objects that are nested several times. To fix that, you can select all objects and unparent them by pressing the keyboard shortcut Alt plus P, and then select Clear and Keep Transforms. And then you should see that now you have a bunch of empty and mesh objects in your scene. Usually I delete all empty objects, but from my few tests, it seems that they are not causing any major issues if you leave them in the scene when you are exporting the model. Another thing that lots of people forget to do, and which I have mentioned before, but I will remind you again, is to make sure that your vehicle is facing towards the positive x-axis. Other issues are mostly prevented by the add-on, but if you don't want to use the add-on, then maybe skip this video further to the part where I show the no bone rigging method. Or if you want to rig it manually with bones, here are the main things you should look at before exporting your model. So I will repeat again. First thing, make sure that your vehicle is facing towards the positive x-axis. And before rigging your mesh to the rig, apply scale and rotation to all meshes and armature to avoid random scaling issues. You can quickly do that by selecting all objects and using the Ctrl+A keyboard shortcut and selecting rotation and scale. And also apply all mesh modifiers to avoid some modifier issues when rigging. And then things will differ depending on if you want to export your model in the FBX or GLTF format. If you want to export in the FBX format, your root and wheel bones need to be oriented so their x-axes are looking to the front of the vehicle, z-axes are pointing up, and y-axes are pointing to the left from the model. Also, you need to make sure that either your scene unit scale is set to 0.01 and your armature scale is set to 1, or your armature scale is set to 0.01 and your scene unit scale is set to 1. Then in the FBX export settings, in the geometry section, set smoothing to face, and in the armature section, uncheck the add leaf bones. For the GLTF format, your root bone and wheel bones need to be oriented so their x-axes are looking to the front of the vehicle, their y-axes are pointing up, and their z-axes are pointing to the right from the model. And you don't need to do any changes to the scene unit scale. Just make sure that armature scale is set to 1. And for the export settings, the default settings should be good enough. So, why exactly do we want to avoid red parts in Blender when checking for normals? Red means that you are seeing a back face of the mesh. So for example, if I had a red part here on the vehicle and imported it into the Unreal Engine, I will see that the red part seems invisible. But in reality, because the normals are facing the other direction, it thinks that I want the material to be shown on the other side of the part. I could fix that in the Unreal Engine by changing the material to be two-sided, but two-sided materials are more expensive to use. But if you don't care much about performance, you can make material two-sided by checking the two-sided checkbox in the material details panel. Or if you are using material instances, then you can look into the material property overrides and look for the two-sided property and check if the second checkbox is checked. If it's not, check the first checkbox to override the property and check the second checkbox. If you imported your model materials by using the GLTF importer, then there's a chance that those materials already are two-sided. At least they are two-sided for me. I don't recall if I set them to be like that or if they are like that by default. But if you do care about performance, then you might want to return to Blender and maybe do some adjustments to your model. But before you do anything, it's probably a good idea to think about if you even need to fix all issues with normals. Like for this model, if in a game there's no intention to show the car upside down, then there's no need to fix these issues with normals, because the player will not be able to see them anyways. But if you have normal issues like this, then you can just select the problematic part in the edit mode and use the Alt+N keyboard shortcut and flip it. But not always just flipping normals will fix the issue. Like for this car's bumper, it will just make the issue worse. Sometimes you can be lucky and fix an issue by separating a part out of the mesh and then applying a solidify modifier on it. but sometimes it might not give you good enough results, so in the end you might need to just model the other side of the part manually. So, just like rigging with the addon, make sure that your vehicle body and wheel meshes are separate mesh objects. Then make sure that your wheel origins are at the center of them, since the bones will be placed at the mesh origins. If they are not, select all your wheels, then click Object, and then Set Origin, and then Origin to Geometry. And that should put wheel origins at the center of them. And then select all objects, and press Ctrl+A, and apply rotation and scale. Then select all meshes, and make sure that the body mesh is the active one. The active mesh outline will have a lighter color. You can change the active mesh by holding down the Shift key and clicking on it until it is active. After meshes are correctly selected, press Ctrl+P and select Object. And now you can see that the wheels are parented to the vehicle's body. Then rename meshes to the bone names you want to see in the Unreal Engine, and then if you want to export it in the GLTF format, simply export it with the default settings. And when you import it in the Unreal Engine, in the import window, set the Force All Mesh as type to Skeletal Mesh. And now you will see that it has imported the mesh and its bone hierarchy looks just like your object hierarchy in Blender. Also, there's an additional parent bone, but in my few limited tests, it seemed that it doesn't really affect anything. If you know if there's an import or export setting that can remove it, let me know. And then you can set it up just like I showed it before in this video. The only difference is that for physics assets, you will need to select the second parent bone as a root bone for physics body generation. But if you want to export it into the FBX format, then you will need to do some more work. You either need to have the scene unit scale set to 0.01 or have the mesh scale set to 0.01. So let's start with the easiest one, by setting the unit scale to 0.01. So after you parent your objects, set the scene unit scale to 0.01 and then upscale the model 100 times, because after changing the unit scale, the model becomes smaller. And then select all objects and press Ctrl+A and apply scale. Also, after changing the unit scale, you might notice that the viewport's view distance has changed. To fix that, in the sidebar's View tab, change the clip start to 0.01 meters and the end to 1000 meters. And now you can export it. And in the export settings, set smoothing to face, and when importing it in the Unreal Engine, just like for the GLTF format, set the Force All Mesh as type to Skeletal Mesh. And then you will see that it imports it just like the GLTF file with the second parent bone. If you don't want to change the scene unit scale, then before parenting anything together, select all objects and scale them up 100 times, and then apply scale on them by pressing Ctrl+A and then selecting scale, and then scale them down 100 times. And now you will see that your mesh objects will have scale set to 0.01. Now parent them together and export and import the model just like before. This method is nice if you want to rig a basic vehicle rig, but it has a few drawbacks if you compare it to traditional rigging. For example, if your vehicle model has suspension and you want to rig a spring for it, or you want to rig a long elastic antenna, then with this method you will not be able to do that. Or maybe you want to make a vehicle that can have different sets of wheels in the Unreal Engine. To quickly set something like that up, you need a vehicle rig without wheels in the Unreal Engine. And with a traditional rig, you can quickly export just a rig without wheels from Blender by selecting the body mesh and rig, and then in the export settings, you will just need to check to export only selected objects. Or if you are making a more modular vehicle, then you might want to export just a rig without any meshes attached to it. But if you wanted to do that with this method, you will need to replace each object with an empty object. For example, you want to make a vehicle that can change different sets of wheels at runtime in the Unreal Engine. So let's have a quick look at how to do that. First, we need to have a rigged vehicle in the Unreal Engine without the wheels. So in Blender, select everything except wheels and then export it. And in the export settings, check to export only selected objects. After that, import it into the Unreal Engine and set it up in the same way as you would set up a regular vehicle. At the end, you should have a drivable vehicle that looks like it's floating in the air. After that, export all wheels or a single wheel from Blender. For my model, a single wheel should be enough, since all of them are the same, but for demonstration purposes, let me show how I would export all of them at the same time. To do that, select all wheel objects and then reset their locations by pressing Alt+G. And now you should see that all wheels are at the center of the 3D space. Then, while only the wheels are selected, export them. If you're exporting into the GLTF format, make sure to check to export only selected objects, and in the Data tab, uncheck skinning to not export any rig data. And if you're exporting into the FBX format, make sure to check to also export only selected objects, and make sure that in the object types, armature is not selected and mesh is selected. To export a single wheel, instead of selecting all wheels, just select one wheel and do the same steps. After that, import it into the Unreal Engine, and if you exported it right, each wheel should be imported as a static mesh. Then open the vehicle blueprint, and under the mesh add the static mesh component. And then, as a static mesh, select the just imported wheel mesh, and as a parent socket, set one of the wheel bones. Then change collision preset to no collision, and in the same manner, you can make the other wheels. If you have only a single wheel mesh, then you might need to rotate some wheels 180 degrees to have it in the right orientation, and after that's done, you should now have a vehicle with wheels. And if it's flying around like this when you try to drive it, make sure that all your wheel collisions are disabled. And now if you want to change the vehicle's wheels, you can do that by changing each wheel component's mesh. For example, I have this blueprint, and if I play a game and press 1, the vehicle's wheels will change. And by using the same principle, you can make a vehicle that can change more parts than just wheels. In the previous section, I showed how to make a vehicle that can change wheels. But what to do if you change wheels to different sized wheels? Like in this example, if I change my wheels to smaller sized wheels, now it looks like the car is floating in the air. If you have used the Unreal Engine before, then you might think that you probably can change the wheel size at runtime by setting some values in the vehicle movement component, but if you try to look into it for some wheel variables, you will not find anything. And if you used the Unreal Engine 4 before, you will notice that you also cannot get things like engine rotation speed from it. If for example, you want to make a tachometer user interface. So to get to those values, you need to cast the vehicle movement component to the chaos wheeled vehicle movement component. And from there, you can get or set at least some of the vehicle values you might need. So for example, if I want to change the wheel size, first at the begin play event, I will cast the vehicle movement component to the chaos wheeled vehicle movement component and save it as a variable. So I wouldn't need to cast it every time when I want to change something. And then, in the place where I change the wheel meshes, I can use the chaos wheeled vehicle movement component to set wheel radius for each wheel. And also, if I want to make a tachometer, I can get the engine rotation speed from there. So if you want to change or get some data about the vehicle at runtime, you probably should look in the chaos wheeled vehicle movement component. Somewhere before, in this video, I showed how to rig a steering wheel or other things like that, but I didn't show how to control them in the Unreal Engine. So for example, I have a steering wheel, and if I want to control it, I can do that in the animation blueprint by either using animation blueprint nodes or using a control rig. Let's look at how I can control it by using the animation blueprint nodes. So first, in the animation blueprint, I'll make a float variable called steering angle. And then I will create a transform bone node, and as a bone to modify, select my steering wheel bone and change the rotation mode to add to existing and change the rotation space to the bone space, since I want to rotate bone around its own axis. And then split the rotation input, and now I need to figure out which is the right axis to rotate the steering wheel around. So, if I compile the blueprint and then select the transform bone node, I will see that in the animation blueprint's 3D viewport, I can see the rotation gizmos over the steering wheel. And I can see that the blue gizmo is the one that goes around the axis I would want my steering wheel to rotate around. And if you look at the bottom left corner in the viewport, you will see that the blue color is for the Z axis. So I need to hook my steering angle variable to the Z rotation. Or I could have just played the guessing game and just connected the variable to a random axis, compiled the blueprint, and then at the bottom right panel, changed the steering angle default value and watched if the steering wheel was rotating in the way I want. And now, by changing the steering angle variable in the animation blueprint, I can control the steering wheel. Now let's look at how we could control the bone by using the control rig. So, in a control rig, just like in the animation blueprint, I will make a new float variable called steering angle and make it public by clicking on this closed eye icon to make it open. Then compile the control rig, and now if I go back to the animation blueprint and click on the control rig node, I can see that in the details panel under the input section there's my just created control rigs variable. And to expose it further to the animation blueprint, I'll check the use pin checkbox. Now I can hook the animation blueprint's steering angle variable to the control rig. And now by changing the variable in the animation blueprint, it will also get updated in the control rig. And now in the control rig, I can add the offset transform node. As an item, select the steering wheel bone, and in the rotation input, create a new rotation from Euler angles. And to find to which axis I should connect the steering angle variable, I can play the guessing game like I showed before in the animation blueprint. And now let's look at two ways how we can change the animation blueprint values from the vehicle blueprint. First, at the begin play event, I will get the anim instance of the mesh and then cast it to its animation blueprint class and save it as a variable so I don't need to cast it every time when I need it. Then, for example, I have this function that returns the largest steer angle from the front wheels. I will connect it to the event tick and then I will directly set the steering angle to the animation instance variable I created before. And now, if I drive the vehicle, I will see that the steering wheel is rotating in the opposite direction, and it's not rotating a lot. But it's an easy fix by just multiplying the angle either in the vehicle blueprint by -2, or you can also multiply it in the animation blueprint. Or instead of updating the steering angle from the vehicle blueprint, you can save the steering angle as another variable in the vehicle blueprint. And then, in the animation blueprint, open the event graph and on the begin play event, cast the pawn owner to the vehicle blueprint and save it as a variable. And then, on the update animation event, check if the vehicle pawn variable is valid and then from it get the steering angle value and set it to the animation blueprint steering angle. And now you should see the steering wheel rotating when driving the vehicle. Right now, I just showed a basic example of how you can communicate between the vehicle blueprint and animation blueprint to control a bone. There are a lot of animation blueprint and control rig nodes you can use to control bones. And also, there are many other ways you could communicate between vehicle and animation blueprints. You might notice that when you're driving a vehicle, its wheels might not look that good, and that most likely is happening because you have a motion blur enabled. You can disable it in the project settings, or if you want to preserve the motion blur, you can replace the wheel controller in the animation blueprint with the stagecoach effect wheel controller, and then try to change its values until you find something that might look good enough for you. Also, to make it even more realistic, you can add the radial motion blur on the wheels. I have never done that myself, but Unreal Engine has a page about that in their documentation. And also, there's a tech talk video where they mention what they did with the motion blur in the Matrix Awakens demo. You can find the links to the documentation page and the video in the description.